The seemingly simple action of opening a door holds a secret to perfect baking and culinary mastery. Unlocking this hidden knowledge reveals the precise chemical transformations happening right in your kitchen. Every time you cook, you are essentially conducting complex chemical experiments with incredible precision. From fluffy cakes to crusty breads, food science dictates the outcome of your culinary efforts. Understanding these fundamental chemical reactions transforms a good cook into a truly exceptional one. Many crucial cooking moments hinge on subtle indicators, often overlooked by the untrained eye. These are the doorknobs of cooking chemistry, tiny signals announcing profound changes in your food. Imagine knowing precisely when your dough is perfectly kneaded or your custard is ideally set. Recognizing these critical points ensures consistent results and prevents common kitchen disasters. This knowledge allows you to control the science rather than just passively observing its effects. We are talking about mastering the invisible forces that shape texture, flavor, and aroma. Discovering these doorknobs changes how you perceive every ingredient and cooking technique. Consider bread making, a perfect example of applied food chemistry and physical transformation. You combine flour and water, initiating a process that will eventually yield a delicious loaf. Flour contains two primary proteins, glutenin and gliadin, which are key to bread structure. Adding water activates these proteins, allowing them to link together and form a gluten network. This network is like a microscopic elastic scaffolding, trapping gases and providing chewiness. Kneading the dough then develops this gluten, strengthening it into a more resilient structure. But how do you know when this crucial strengthening is complete? This brings us to a prime culinary doorknob, the window pane test for bread dough development. You take a small piece of dough, gently stretching it between your fingers until it becomes translucent. If the dough stretches thin enough to see light through it without tearing, it has passed the test. This translucent membrane, resembling a delicate window pane, signifies optimal gluten formation. It means the gluten strands are strong, elastic, and ready to hold the gases produced by yeast. Failing the test indicates insufficient kneading. The dough needs more work to build its strength. Yet the doorknob concept extends far beyond just bread. Think about caramelization, where sugar molecules undergo a series of complex chemical reactions. Heating sugar past its melting point triggers a cascade of breakdown and rearrangement processes. This creates hundreds of new flavor compounds, from nutty to buttery, transforming simple sweetness. The doorknob here is the precise temperature at which these reactions begin to dominate. Too low and you just have melted sugar. Too high and you get burnt, bitter compounds. Chefs often rely on visual cues, like color change, to hit this exact caramelization doorknob. However, visual cues can sometimes be deceptive. Consider the Maillard reaction. Visual cues can sometimes be deceptive. Responsibles can sometimes be deceptive. This non-enzymatic browning occurs between amino acids and reducing sugars under heat. It generates thousands of new aromatic compounds, creating incredible depth of flavor. The doorknob for the Maillard reaction is often the moisture level on the food's surface. A dry surface allows the temperature to rise quickly, initiating this crucial flavor development. Too much moisture, and the energy is spent evaporating water, preventing browning effectively. But what happens if you miss these subtle signals entirely? Even something as simple as whisking egg whites involves understanding a molecular doorknob. Mechanical agitation denatures the egg proteins, causing them to unfold and create air pockets. These proteins then rebond around the trapped air, forming a stable foam for meringues. The doorknob is the point just before overwhipping, where the foam is firm but still glossy. Past this point, the proteins become too tightly bound, causing the foam to curdle and separate. Recognizing this precise moment ensures light, airy desserts every single time you bake. Understanding these doorknobs changes everything. Mastering these culinary doorknobs empowers you with unparalleled control over your cooking. You move beyond simply following recipes, gaining a deeper, intuitive understanding of ingredients. This precision allows for consistent high-quality results, elevating every dish you prepare. Imagine baking bread that consistently achieves the perfect airy crumb and crispy crust, or searing a steak to its ideal internal temperature, producing maximum juiciness and flavor. This scientific approach minimizes waste from failed attempts, saving both time and ingredients. Furthermore, it fuels creativity, enabling you to confidently experiment with new techniques. You can adapt recipes, troubleshoot problems, and invent entirely new culinary creations. Understanding why things work, not just how, unlocks a new dimension of gastronomic pleasure. It's like having a secret language with your food, anticipating its every molecular need. This knowledge transforms cooking from a chore into a fascinating, continuous learning journey. You develop a chef's intuition, recognizing subtle cues that others might completely miss. This deeper connection to your food ultimately enhances the enjoyment of eating itself. Every meal becomes a testament to your mastery of intricate chemical transformations. These doorknobs are the keys to unlocking a world of culinary excellence and scientific wonder. Recognizing these chemical doorknobs truly empowers you to master the art and science of cooking. If you found this exploration fascinating, subscribe for more incredible insights into science and life. Share your favorite cooking doorknob moment in the comments and hit that like button.